Hi, my name is Alison Rose, and this is my presentation 2 for Abstract Algebra and Galois Theory. This is for Math 676 at Minnesota State University, Moorhead. The objective of this presentation is to prove and provide an example of Proposition 6.2.4 in the course notes. Proposition 6.2.4 states, if n is an integer larger than 1, then the integer modulo n star is the set of all positive integers less than n which are relatively prime with n. So let's take a look at what that means. First, we're going to use definition 6.2.1, and we define the integers modulo n star to be any element of the integers modulo n which multiply by another element in the integers modulo n to produce 1 mod n. In other words, the only elements in the integers modulo n star are those with multiplicative inverses. We start the proof by choosing two elements in the integers mod n star, such that the product is 1 mod n. Using algebra, we are able to get the second equation, which looks very similar to Bezout's identity. Bezout's identity states, for non-zero integers a and b, let d be the greatest common divisor of those two integers a and b. Then there exists integers x and y such that ax plus by is equal to the greatest common divisor of a and b, which they're calling d. Looking back at this prior equation here, you can tell that this is very, very similar. In our case, the greatest common divisor of a and n is 1, or we have the greatest common divisor of b and n is 1. Either way, a and b are relatively prime to n, because the greatest common divisor is 1 in both cases. Therefore, the integers modulo n star is the set of all positive integers less than n, which are also relatively prime with n. And this was the desired claim that we have proven. Now, here is my example. If we consider the integers modulo 8, that is the set containing 0, 1, 2, 3, 4, 5, 6, and 7. Those are the possible remainders of a number when divided by 8. Now, if we consider the integers modulo 8 star, the elements which are in that set are anything that has a multiplicative inverse. So anything that has another integer in that set which multiplies to be 1 modulo 8. Or in other words, anything that has a remainder of 1 when multiplied by another integer when divided by 8. So, for example, 1 times 1 is 1, and which is equivalent to 1 modulo 8. That's a pretty simple one. But 3 times 3, that gives us 9, and when we divide 9 by 8, we have a remainder of 1. So 9 is equivalent to 1 modulo 8. 5 times 5 is 25. When we divide 25 by 8, we do have a remainder of 1, so 25 is equivalent to 1 modulo 8. And again, 7 times 7 is 49, which is also equivalent to 1 modulo 8. So the integers 1, 3, 5, and 7 are all self-inverses, which means that when I multiply them by themselves, they are equivalent to 1 modulo 8. And so they are all contained in the set integers modulo 8 star. That is how this set has been defined. Now, if we look at the other integers in the integers modulo 8, you can see why they are not in the integers modulo 8 star. And that is because if we were to take any of these integers, 0, 2, 4, or 6, and find their multiples modulo 8, they do not generate 1. So if we take 0 and multiply it by anything, it's never going to produce anything other than 0 modulo 8, which makes sense. So that is definitely not in our integers modulo 8 star set. Any multiple of 2 will generate the remainders 0, 2, 4, 6. And 8 is in there as a typo. I thought I deleted that. So we will get rid of that, because 8 modulo 8 is 0. Now we have 4. If we were to find the multiples of 4, either we're going to have a remainder of 4 or we're going to have no remainder at all, which is 0 modulo 8, so we can't generate 1 using multiples of 4. And again, same situation with the number 6. If we find all the multiples of 6, it's either going to generate a remainder of 0, 2, 4, or 6 when we consider modulo 8 arithmetic. So therefore, because these integers, when we consider their multiples, they do not have a multiplicative inverse. In other words, they don't generate 1 when multiplied by another integer in integers modulo 8. They are not in the set integers modulo 8 star. Now, how does this all relate to Galois theory? This particular group, the integers modulo 8 star, relates to Galois theory through theorem 6.2.20, which states that the Galois group of x to the n minus 1 over the rationals is isomorphic to the group we just defined, the integers modulo n star. So that is how it all relates to Galois theory. I hope that you have enjoyed my explanation of the proof of theorem 6.2.4, and I hope I have explained the example of the integers modulo 8 star and how it all relates to Galois theory. So thank you for listening, and I hope you have a great evening.